Hello everyone. So today we are going to start a new series. It's linked list. So I have divided that series in two parts, part 1 and part 2. In the part 1, we will be talking about the basics of the linked list, types of the linked list and some operations related to the linked list. And in the second part, we will be solving some problems related to the linked list. So without any delay, let's start the video. What is linked list? So linked list is nothing but a list of interconnected nodes. As we can see here, it's one node, it's another node. So these are connected with some link. This is the pointer. We keep the starting node as an head, and last node keeps the null in its next pointer, as you can see here, because it don't need to point to any next node. So these are some properties of the linked list. Like successive elements are connected by pointers, as you can see here. These are connected by pointers. Last element points to null, as we can say here. It can grow and shrink in size during execution of a program. Does not waste memory space because we don't have to allocate memory to linked list in advance. As we need to create a node, so we will be creating that node and new memory space will be allotted to that node at the runtime. So in advance we don't have to keep the memory. So that's why we don't waste any memory space. So arrays were already there. Then why did we need linked list? So there are some advantages and disadvantages of both arrays and linked list. So what are these? In case of arrays, we can access the elements faster. How? Like in case of arrays, we just have to pass the index of the element and we just get the element at that index. But in case of linked list, like we will have to traverse all through the linked list and we will have to find that node at the nth position. So this is a bit costlier than arrays. In case of arrays, like memory is allocated in a continuous manner. So how? Like if we are creating an array of 10 elements, so what will be happening? A continuous memory block will be allotted to all the 10 elements of the arrays in a single go. But in case of linked list, what happens? Like as we create the node, only memory block for that node is created. When we will create the next node, then only memory block will be allotted for that next node. So arrays are fixed in size, but linked lists are variable in size. One block allocation, as we discussed, all the elements are allotted in a single go. Resizing is costly in the arrays. How? Like say we have created an array of 10 elements here, and then like we have to create an array of 10 elements because like we have filled all the 10 elements in the array and now we have to fill next elements. So what we will have to do, we will have to create a new array with like more elements, and we will have to copy all the previous array elements into the new array. But in case of linked list, what happens, we don't need to face this kind of problem because if we have to create a new list, so we will be creating the node and we will be assigning that node to the linked list. So we don't have to copy paste all the previous linked list because we are modifying the existing linked list. That's why we say it's variable in size. So what are the operations we can do on the linked list? So these are the basic operations like insertion, deletion, and deleting all list, counting the elements, and find the nth node at the end of the list. What are the types of the lists? Singly linked list, doubly linked list, circular linked list, memory efficient doubly linked list, unroll linked list, and skip list. So we will be talking one by one about these types. So this is the complexity, time complexity representation of linked list arrays and dynamic arrays. So indexing is done in ON, in arrays it's O1, in dynamic array it's O1. And insertion and deletion at the beginning happens in O1 at array list. How? Like if we have to insert, if we have to delete some element from the beginning, so we just have to come to that node. We will have to like point its next to null, and we will be deleting it, and our head will be pointing to it. So how much nodes we had to traverse? Only one, so it's O1. But in case of arrays it's ON. How? Like say this is the array and this is the first array index. So if we have to delete that index, so we will have to shift all the elements which are falling after that element to upwards direction, right? As you can see, so we will have to traverse all the n elements after that first node, after that first element. So it's on. Same in the case of dynamic array, it's on. Inserting at ending in case of linked list, it's on. How? Because we will have to traverse to all the n nodes, and then we will have to assign the new node in the end. So how much node we had to traverse? On. So it's on. But in case of arrays, it's O1. How? Because we keep a pointer of the indexing in the array. So we just have to go to the last index and assign the new element to that index. It's O1. So same as in the case of dynamic arrays, it's O1. Deleting at the ending, it's on in case of linked list and O1 in arrays. As we discussed earlier, like we will have to go to the end and we will have to delete. So we how much nodes we had to traverse? N nodes. Insertion at the middle, on, because we will have to traverse n nodes and we have to delete that element. In case of arrays, as we discussed, like we will have to shift all the later on elements upwards. Deletion in middle, again it's on. It's on in arrays as we discussed, and on in dynamic arrays. So wasted space. So in case of nodes, like we have to keep two things. Like one is data and another is next pointer, like which will be pointing to the next node. So extra space occupied by that next pointer, this is the wasted space as we compare with the arrays. But in case of arrays, we don't need to keep any next index, so we just have to keep the data in the memory. So only that space is utilized for what data is to be allotted. So let's first discuss about the singly linked list. So what is a singly linked list? In singly linked list, like we just keep only a single pointer to the next node, and we can move in unidirection only, like that is forward. So as you can see in the diagram, we can move in forward direction only. And this is the representation of the node in Java. So we have created a class, we have keep one data element and one node element. So in the node we will be keeping the address of the next nodes. So what are the operations on the linked list? So these are the traversing the linked list, inserting an item in the list, and deleting an item in the linked list. Traversing the linked list. So this is the program written in the Java code to traverse the linked list. So what we will be doing? So we will be having an address of the head. So I have assigned it into the current, and like we will be moving my current address to next nodes. So as you can see, I have drawn it here. So initially my head was there, so I printed its data, then I pointed my head to the next. So next time my current will be pointing here, then I will be coming here. So that while loop will be running till we will not get null in the current. So we will come here, and here we will be encountering null in the current, so we will be printing all the elements. So time complexity for that will be on because we have to traverse n nodes, and o1 because we did not use any extra space. Insertion in the linked list. So insertion can be done in three forms. So insertion at the beginning, insertion at the end, and insertion in the middle of the list. First we talk about the insertion at the beginning. So in that case, what we will have to do? We will have to create a new node, and we will have to point that new node to the head of the existing linked list, as you can see here, and we will be updating head to the new node. So now this will be our new head. Insertion at the ending. In that case, what will be happening? We will have to traverse to end of the linked list, and as we will encounter the null, we will find that it's the end of the linked list. Then we will be creating a new node, and we will be pointing next of that node to null, and we will be pointing our current node to that node. So yeah, as you can see here, insertion at the middle of the linked list. So in that case, what will be happening? We will have to traverse to that point where we have to insert the element. So say if we have to insert the element at the third position, so we will have to move two positions, 1 and 2, and then we will be pointing second position node to the new node, and new node will be pointing to the third position, as you can see here. Now we will talk about the deletion. So deletion also can be done in three forms: deleting the first node, last node, and intermediate node. Deleting the first node. So in that case, we just need to come to the first node, and we have to keep its address in temp, and we will be moving our head to the next pointer, and our head will be updated with the address of that next pointer, and we will delete that node. Deleting the last node in a singly linked list. So we will have to traverse all the nodes of the linked list. We will have to come to the end of the linked list, and we will have to keep the two pointers. So will be one pointer will be to track the last node, and one pointer just previous node of that last node. Once we encounter the null, we found the last node, so we will be pointing null to the previous pointer, and we will be deleting that node. Deleting an element from the intermediate position. So same as we have to delete the third element, so we will be traversing two positions, 1 and 2, as we can see here, and then we will be pointing second node to the fourth node, and third node will be released, so we will be deleting it. So till now we talk about the singly linked list, but now we will be talking about the doubly linked list. So doubly linked list is what? So doubly linked list basically contains two pointers, one for the next node and one for the previous node. As we can see here, we have three things here. One is data, one is pointer for the next node, one is pointer for the previous node. So here we will be requiring one more memory space for the previous pointer. Then Operations on the doubly linked list, like as we did for the singly linked list, same for the doubly linked list, like deletion from the insertion from the head, insertion at the tail, and insertion in the middle. Inserting a new node in doubly linked list at the beginning. So here we will have to create a new node, and next of the new previous of the new node will be containing null, as it's going to be the first node, and next of this new node will be pointing to the head, and previous of the head will be pointing to this new node, and we will update the head with the address of this new node, and the new node has been assigned to the linked list, as we can see here. Inserting a node in doubly linked list at the ending. So in that case, we will have to come to the last node. So as we will encounter the null, we found the last node. We will be creating the new node, and we will be pointing next to new node to null, and we will be pointing previous of that node to the last node of the list, and the last node will be pointing to the new node of the list, as you can see here. Inserting a node in doubly linked list at the middle. So here, like, we will have to come to that position where we have to insert the node. So in that case, we have to insert the node at the third position. So we will have to come to the second position here. We will be creating a new node, and then we will be pointing next of that new node to fourth fourth node here, as you can see, and previous of that node will be pointing to the second node, as you can see. And same thing we will have to do, like we will have to point the second node next to the new node, and third node previous to the new node here. Now insertion is done, so deletion in the doubly linked list. So deletion from the first node, deletion of the last node, deletion in the intermediate position. So deleting the first node in linked list. So what we will have to do, we will have to come to the first node, and we will be keeping it into temp, and then we will be moving our next our position to the next node, because we have to delete the first node, and we will be assigning a new node with the head. So now our head will be this one, as we can see here. This is our new head, and we will be like assigning previous of that new node to null, and this node will be released. Deleting the last node in the doubly linked list. So we will have to keep the two pointers. One is for the end of the linked list, and one is for the second last node of the linked list. So as we will encounter the last node here, and we will be keeping the second last node here. So in the second last node, we will be pointing next to the null, as we can see here, and we will be pointing last nodes previous to the null, and here the last node will be released, and then we can delete it. Deleting an intermediate node in doubly linked list. So say we have to delete the node from the third position. So we will have to move to steps 1, 2, and then we will be pointing the second pointers next to the fourth position, like it will be like third nodes next, and then we will be pointing the previous of this fourth node to the second of this linked list, and then like we will have to delete the previous and next pointers of this third node to null. So we will be assigning previous of this third node to the null, and next of this third node to the null, and this node will be released, and then we can delete this node. Okay, so enough of linked list and doubly linked list. Now there is a third form of linked list. This is circular linked list. So this is same as linked list, like it keeps only a single pointer, like a singly linked list, but it doesn't contain any null at the end, because its nth node points to the beginning. Inserting a node at the front of the circular linked list. So in that case, we will be creating a new node, and we will be pointing that new node's next to the head, and then we will be moving to the end of the linked list. And as we discussed earlier, like when next of the node will be having its pointer to the head, so this way we will be finding the last of the circular linked list, and that last will be pointing to the new node. And in that way, like it will be like new node will be connected, and then we will have to like update our head to the new node. So our head is updated to the new node, so this is how new node has been added. Inserting a node at the end of the circular linked list. So what we will have to do, like we will have to like first we will have to create a new node, and we will be assigning the data to the new node, and next of the new node will be pointing to the head of the linked list, and then we will have to traverse to the end of the linked list. And how we will find the end, like at the end the last node of the linked list will be pointing to the head, so that condition we can give into the code, like when last node's next will be the head, so this is the last node, and then that last node will be pointing to the new node here, as we can see. And deleting the last node of a circular linked list. So again, like we will be keeping two pointers, one for the second last node and one for the last node. So once we encountered the last node, so we will be pointing second last pointer to the head, and we will be pointing next of the last node to null, as we can see here. And like and then we can dispose it, and like our second last pointer now point to the head. Deleting the first node in a circular linked list. So what we will be doing, like we will have to find the last node of the circular linked list. As we found the last node, so we will be pointing next of the last node to the next of the head here, and like heads next will be pointing to null here, and we will be updating our head to the second node, because first node we have to delete, so now it's released, so we can delete that node. Okay, so like in that video we talked about singly linked list, doubly linked list, and circular linked list, and some basic operations like insertion, deletion at the ending, at the beginning, and at the intermediate level in the linked list. So now we are like left with three linked lists, like memory efficient doubly linked list, unroll linked list, and skip lists. So if you want me to make some videos on all these lists, so please comment me in the comment box. Thank you for watching.